Good morning, and welcome to another boring math video. We're starting chapter 7, the linear functions chapter. You're probably going to find this to be the most challenging one of the chapters that we go through in this lovely distance learning world. But the very first thing, the most important thing, is a carryover from what you learned in the last chapter, which is slope. We're going to review the slope formula and just see how slope can be used to graph a line. And I can't oversell how important this formula is for the whole of chapter 7. So it's really, really important that you understand it. Okay, so we'll get started. The slope formula is simply a mathematical way of talking about something that we talked about in chapter 6, and this idea that slope is simply a measure of the steepness of a line. Okay, so the bigger the number for slope, the steeper the line that's assigned to slope. From a completely flat slope or line which has a slope equal to 0. Remember, the variable for slope is m, okay? To a perfectly vertical line which has an infinite slope. The number is so big we can't even make sense of it, and so we say that for a vertical line the slope is undefined. Okay? Recall that, and there's a nice, there we go. So just a nice summary of what you learned in chapter 6. You've kind of got 4 different ways that the slope of a line can shake out. You can have slopes that go upward as you go from left to right, that'll be positive. The opposite would be downward as you go from left to right, that's negative. A totally horizontal line, as I just said, has a slope of 0. A totally vertical line has a slope that's undefined. Okay, so those are kind of the 4 groups you end up with. Taking a look at the formula, the slope formula, m, is simply equal to y2 minus y1, the difference in y values, or the rise, divided by x2 minus x1, the difference in x values, which is the horizontal difference, or the run. Okay? Now, it's really important to understand that you can find the slope by picking any 2 points on the line. Okay? It doesn't matter which points they are. You want to pick lines that are points that are easy to work with, hopefully non-decimal or non-fractional numbers if you can get away with it. It just makes it easier, okay? So if we take a look at some examples where you're determining the slope, for example, the first one, your formula is slope equals y2 minus y1 over x2 minus x1. You might ask, which one is the 2, the x2 and the y2? Which one is the 1, the x1 and the y1? It doesn't matter, okay? You can just arbitrarily decide your first ordered pair is going to be your x1 and your y1, and your second ordered pair is going to be your x2 and your y2. Just make sure that the numbers in the ordered pair will both be assigned the same subscript, okay? So if you choose this as your x2, this one has to be your y2. After that, it's just a matter of subbing in numbers, okay? Now remember, think of this as a formula that has 5 variables, right? You've got your m, you've got your x2 and your x1, you've got your y2 and your y1. Ooh, look at that. And so that's 5 variables. So our y2 in this case is 8. Whoops. sorry, it's early in the morning, is 8, and our y1 is 5, so we get 8 minus 5. Our x2 is 3, and our x1 is 1, so we get 3 minus 1. And when we subtract, we get 8 minus 5 is 3, 3 minus 1 is 2, so our slope for A is 3 over 2. Now that immediately tells you something about the line. If we see that the slope is a positive number, we're not sure how steep this line is going to be, but one thing we know for sure, it's going to look like that, right? It's going to go up to the right as you go from left to right. Okay? We'll do one more. How about D? We'll do D. Okay, so let's just go up here to D. Now for D, our y2 is 4 and our y1 is negative 5. So that gives us 4 minus negative 5. Our x2 is negative 3 and our x1 is 2. So that gives us negative 3 minus 2. Now remember, when you're subtracting a negative, it's like adding a positive. Okay? So we can think of this as 4 plus 5, or 9. Negative 3 minus 2 would be negative 5. Leave it as a fraction. Don't change these into decimals. Okay? If it simplifies to a nice whole number, fine. Go ahead and simplify it to a whole number. Otherwise, leave it as a fraction. Don't convert it to a decimal. That will make more sense later on. Okay? But for now, just don't convert it to a decimal. Now, by looking at this, since it's a negative number to the slope, and I always like to just move the negative up top here. You don't have to, but it's just something that I've gotten used to doing. I always do it, and so that way there's no confusion. Okay? So, this and this are exactly the same. Also, negative 9 over 5 would also be the same. They all have a negative slope, and that tells us that our line will go in this direction as you go from left to right. It will slope downhill. Okay? Moving on, we'll just take a look at number 2. Number 2, remember how I said a minute ago that you can think of the slope as just like any other formula that has 5 variables? Well, what they've done in number 2 is they've given you a value for the slope. They've said that m equals 3. They've given you a value for your x1 and y1. They've given you a value for your x2, but your y2 is unknown. Okay? So don't get all worried about that. Just as you've done in science and you did in the measurement unit for math, sometimes when you plug in the numbers, you're going to have to rearrange the equation to isolate the variable. So let's do that. We know what our slope is. Now, remember how I said leave the slope as a fraction? Okay? We're going to enter the slope value as a fraction. Okay? So we're going to, instead of just writing it as 3, we're going to write it as 3 over 1. Okay? And you know that you can turn any number into a fraction just by putting it over 1. So there's our slope. Our y2, remember, is unknown. We'll just call it k, because that's what they called it. Our y1 is 4, so we get k minus 4. On the bottom, x2 minus x1, we get 8 minus 2. Okay? So let's simplify this. We can simplify the bottom. 8 minus 2 is 6. So we end up with 3 over 1 equals k minus 4 over 6. And I'm just going to put brackets around this just to show you what the next step is going to look like. So what we have here, you should maybe be familiar with from the measurement unit. What we've got here is a proportion. Remember how you did proportional reasoning in the measurement unit? And remember, to solve for an unknown, if you have a proportion, at this point, we cross multiply. Okay? So we're going to multiply 3 times 6. That will give us 18. Okay? Over here, and you can see why I put it in brackets now, we're going to multiply 1 times k minus 4. So 1 times k minus 4. And what we've done is we've made this a much simpler equation just by getting rid of the denominators. So remember that. Whenever we have denominators in this chapter, we're going to try and get rid of them, okay? And so we did get rid of them. Our next step is to simplify on the left side. Remember that distributive rule. Now you can see why I put brackets around this. 1 times k is k, 1 times minus 4 is minus 4. Well, you knew that, but sometimes it won't be a 1 there. Sometimes it'll be a different number. Equals 18. And now you can see it's a very simple equation. To isolate k, remember we have to get rid of this minus 4. So we do the opposite of subtraction to both sides. We're going to add 4 to both sides. Minus 4 plus 4 is 0, so all we're left with is k. 18 plus 4 is 22. Okay? And so now we know, going all the way back up to here, that this ordered pair will be 8 for our x2 value and 22 for a y2 value. Okay? I'd ask you if you had any questions, but I won't be able to hear you if you do. Okay, so we've already talked about horizontal and vertical lines. This is very simple. You had a question like this in chapter 6. Remember, if you're given a line and you're asked whether it's going to have positive, negative, 0, or an undefined slope, all you have to do is look, okay? This one goes up to the right, so it must be positive. This one goes down to the left, so it must be negative. This one is horizontal. It would have a slope of 0. And finally, over here, you can see an example of a vertical line, and a vertical line has a slope that is undefined. Okay? Just review. So, you had some questions about this in chapter 6 as well. The idea that if we're looking at kind of a real-world situation, you can calculate slope. In chapter 6, you were calculating the slope of a person descending in a parachute. Okay? Slope is always change in y over change in x. So if you were to calculate the slope of this particular line, the units for your rise or your change in y would be kilometers. The units for your run or change in x would be hours. So the slope that we're talking about, the rate of change that we're talking about, is some number of kilometers per hour, or in this case, the slope tells you something about the speed of something. Okay? So let's take a quick look at this. Yvonne recorded the distances she traveled at certain times since she began her cycling trip. She plotted these data on a grid. What is the slope of the line through these points? So they're asking us to calculate the slope, but more specifically to this problem, they're asking us to calculate her speed, okay? You did this in the physics unit of Science 10. So, here are our points. I'll just make them a little more obvious. And I'm just going to write the ordered pair that corresponds to each of these points. So for this point, you are going across to 1, and you're going up to 24. Very common mistake students make is they'll just count the grid squares. So they would have said that their x is 2 because it's 2 grid squares, and their y is 4 because it's 4 grid squares, and they would write 2 and 4 there. Don't be that person, okay? Look at the scale and figure out what it really means, okay? If we take a look at this one, it's 2 across and 48 up. So there's our 2 points. Now, again, just to make sure you understand, these aren't the only 2 points you could use, okay? If you had a line here, you could pick any 2 points. But they've given us these, and they're nice and easy to work with, so we'll use these, okay? So, to find the slope, remember it's y2 minus y1, x2 minus x1, and then you just plug in the points, okay? We'll pick this as our x2 and y2, so we get y2 minus y1, or 48 minus 24. x2 minus x1 becomes 2 minus 1, and that gives us a slope of 48 minus 24 is 24, 2 minus 1 is 1, or 24. And it's important to use the units if you're given units, if you have a real problem to solve. So it's 24 kilometers per hour. What does the slope represent? Her speed. Okay, so that's how fast she was going. 24 kilometers per hour on her lovely run. Okay? Is the data continuous or discrete? Well, all you need to ask yourself is, are partial values reasonable? So would it be reasonable to talk about 1.5 hours or 1.3 hours? Would it be reasonable to talk about distances of 13 kilometers or 14 kilometers? Yeah, it would be. So in this case, our data is continuous because partial values in between values make sense. And generally, anytime you have something that's measured, you'll have a continuous relation. Okay? So, continuous. This is just another example. We won't bother. Sometimes you are not given a lovely little graph to work with. Sometimes you're given a word problem. And of course, that always introduces a little more difficulty. Okay, so on the first day of school in September, Jody measured the length of her hair. She found that her longest hair was 36 centimeters. At the end of the school year in June, Jody measured her hair again. Her longest hair at this time was 48.5 centimeters. What is the rate of change? Remember, anytime you see that phrase, what they're really saying is, what's the slope? Okay. So rate of change, remember, is your slope. So what they're really saying is, find the slope, and they're saying per month. So, at the very beginning of the school year, no time has passed, so at the beginning, we could say that the time is 0 months, right? It's September 1st. Whoops. Just let me, there we go. Okay, 0 months. And at 0 months, her longest hair was 36 centimeters. Okay? At the end of June, well, at the end of June, 10 months have passed. Okay? So our x value is 10 months. Remember, time is always, always, always going to be an x value. Anytime you're given time, it's x. her longest hair at the end of June was 48.5 centimeters. Whoa, we have 2 points. As soon as you have 2 points, you can always find the slope. Okay? So, what is the rate of change? What is the slope? Slope equals y2 minus y1 over x2 minus x1. Okay? Plug in your numbers. Your y2 is 48.5 and your y1 is 36. Your x2 is 10 and your x1 is 0. That gives you, sorry, I'm just going to go to the side here because there's no more room. Well, maybe we'll go underneath. 48.5 minus 36 is 11.5. Yeah, 11.5. No, sorry, it's 12.5. Like I said, it's really early. And 10 minus 0 is 10. So we have a slope equal to 12.5 over 10. Now, in this case, if we divide, we get 1.25. And what are our units? Well, we're measuring centimeters for our length and months for our time. 1.25 centimeters per month. Okay? Sometimes dividing in a word problem gives you a kind of a more meaningful answer. So what this is telling you is the rate of growth, her hair grows 1.25 centimeters every month on average during the school year. Okay? So like I said, when you are given an actual problem and you have labels on your graph, then the slope actually means something. So in this case, your slope would be kilometers per hour. So you'd be talking about a speed, okay? In this case, you might remember back to grade 9 science, you have something that's measured in grams per milliliter. That would be a density, okay? So something that weighs more grams per milliliter would be denser, okay, like syrup, as compared to something that would weigh fewer grams per milliliter, something maybe like water, okay? This one might be of some importance to you. This one is measured in Y, in dollars, X, in hours. That might be an hourly pay rate, right? At your part-time job, you get paid $15 per hour, okay? So the important thing here is once you give your labels, or once you give your X and Y values labels, your slope becomes meaningful. The last thing we're going to do today is we're going to use slope as a set of instructions to graph a line. Okay? So, remember we said that slope can be thought of as the change in y values over the change in x values, or rise over run. Okay? Well, you can think of that as a set of instructions. And that set of instructions is telling you how to get to a second point if you're given another point. Okay, so let's take a look at number 2. Number 2 gives you 2 pieces of information. If you have 2 pieces of information, either 2 points or 1 point and the slope, you can graph a line. So in this case, we're given a point at -2 and +6. Well, let's plot that. Starting from the origin, Our run is -2, so we have to go to the left, right? Because the left is the negative numbers. So we're going to go 2 to the left, -2, and 6 up, +6. There's our point. -2, +6. Now we have a slope, and that slope, remember, is giving us instructions. It's saying, if you start at this point, you can get to a second point by going, I'm just going to write it nice and big. So our slope is 1/2. Since our 1 is positive, and since our 1 refers to the rise, positive y values go up, right? The further up you go, the greater the positive number. Similarly, with our run, our change in x, it's also positive, and the positive x values are to the right. So a positive run indicates you have to go to the right. So what this is telling you is, if you start here, to get to another point, you have to go up 1. Okay, we went up 1. And you have to go right 2. 1, 2 to the right. Wow. We have our second point. Okay? So again, starting with the point we're given, we go up 1 and right 2. That gets us to our second point. The rest is easy. We simply take a ruler, we join the points, and we've graphed our line. Nothing could be easier. We'll do, why don't we do this one? Okay, so we'll do number 3. So, remember how I said sometimes it's easier to work with the slope as a fraction? This is one of those times. So I'm just going to write this -2 as -2/1. So again, nice and big. Our slope is -2/1. Now, in this case, since our y value is negative, our rise value is negative, we're not going to go up, we're going to go down. So a negative y means you're going down. Our x value is positive. See why I made it into a fraction now? That gives us an x value to work with. Since our x value is positive, that means we have to go in the positive x direction. We have to go to the right. Okay? So, step 1, plot your point. Step 2, use your slope as directions to get to a second point. So, -5, -3, starting at the origin, we have to go -5 across, -3 down, and that brings us to this point, -5 and -3. Okay? Now we use our slope as directions. It tells us from this point we have to go, just let me rewrite this, it's going to get in the way, -5, -3, okay? We have to go down 2, so 1, 2, and we have to go right 1. There's our second point. If you have a linear relation, and all the relations in this chapter will be linear, if you have a linear relation, all you need are 2 points and you can graph your line, right? Because if it's a linear relation, we know it's a straight line. So we can just use a ruler. Whoa, there we go. There's our line. Okay? Hopefully this made some sense to you. This is just more of the same, okay? Where you're given a point and the slope, and you have to plot it. Okay? Now, you don't even really need a grid. All you need to remember is what the numbers in the slope mean. So for instance, for this one, where we have a slope of -1 over +2, that means our run is -1, so we have to go down 1. Our run is +2, so that means we're going to go right 2. Okay? So, if the point we're starting with has coordinates of 3 and 5, we'll start with the y. Going down 1 from 5 would take us from 5 to 4. Okay? If we're starting with an x value of 3 and we're going to the right, that means we're going to go right 2, we're going to go from 3 to 4 to 5, giving us an x value of 5. Let's do one more of those, okay? So this one, we're starting at -3 and 7. Both of our values in the slope are positive, so that means for our run, we're going to go up. For our rise, we're going to go up 3. For our run, because it's positive, we're going to go to the right, and we're going to go 7 to the right. So what's our new value going to be? Well, if we're starting at -3 and we're going up 3, we're going to go -3 to -2 to -1 to 0. Oh, never mind. This is an incredibly common mistake. Be very careful that you don't confuse your x and y values like I just did. Okay? This is our rise number, our y number, right? So, since the top number in our slope refers to y, this is the one that's going to go up 3. We're going to go from 7 to 8 to 9 to 10, giving us a new y value of 10. For our x value, we're going to go to the right 7. So we're going to start at -3. We're going to go -3, -2, -1, 0, 1, 2, 3, 4, or -3 plus 7. That gives us 4. Okay? I hope that made sense. We have come to the end of today's lesson. Again, if you're one of my students, please email me. If you're not one of my students, I hope this made some sense to you. Okay, so email me if you have any questions. Good luck.